Hello, my name is Angel, and I am here to prove the triangle inequality theorem. I chose to do this proof because the triangle inequality has been proven to be quite useful in my analysis class, where we have to prove many theorems and whatnot. Most of the time, the proofs boil down to using the triangle inequality. Also, I like the word triangle, because it's a well-known, simple mathematical term. Basically, what the triangle inequality says is that going in a straight line is shorter than taking extra turns or stops. Let me demonstrate. Here we have a triangle of lengths 3, 4, and 5 centimeters, and each corner can be a point. Let's call this one point A, this one point B, and this one point C. If we travel from point A to point C, this would be 5 centimeters. But if we go from A to B to C, it would be 3 centimeters plus the 4 centimeters, which means that's 7 centimeters just to get to C. If we go from A to B to C, clearly it's faster to just go in the straight direction, straight line right towards C. The triangle inequality theorem has some very useful real-world applications, such as navigation. It's used for GPS, delivery companies, communication signals, and even everyday movement. So like as you see here, we have a straight line. Let's say like you're going from your car to your school, a straight line would be faster. But if you're taking all these twists and turns and corners and whatnot, it'll take longer to get there than it would have been to just go in a straight line. Now, the mathematical definition of the triangle inequality is as follows. Let A and B be any real number. Then the absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. Some definitions pertaining to this theorem that are useful to know here is what a real number is and what the absolute value symbol is. Now, a real number is any number found from negative infinity to positive infinity, whether that be a proper fraction like 1/2, or an irrational number like pi, or a whole number like 1. The absolute value of a number represents a number's distance from 0. It takes whatever is inside of the absolute value and makes it non-negative. So if, for example, we have the absolute value of 2 minus 4, first we solve the expression of what's inside the absolute value symbol. So 2 minus 4 is negative 2. So this would become the absolute value of negative 2. And how far is negative 2 from 0? Well, 1, 2. So the absolute value of negative 2 is just 2, or positive 2. That will come in handy later on. Now let me show you my proof of the triangle inequality. It may seem like a lot, but the core idea of my proof is squaring both sides of absolute value of x plus y and the absolute value of x plus the absolute value of y, and then algebraically expanding the expressions that follow, as I did right here and right here. On this part of the proof, I show the two important cases of x times y is greater than or equal to 0, meaning that they're positive, and the other case where x times y is less than 0 when they're negative. These cases lead to proving why the triangle inequality holds true. Afterwards, I go back to the expanded inequality of the absolute value of x plus y squared is less than or equal to the absolute value of x plus the absolute value of y all squared. And remember that this is the same as this, as we demonstrated earlier when we did the algebra. And this is the same as this right here, remember? And then we can break these down to the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y, which proves the triangle inequality. Being rigorous about explaining my process and steps is integral in showing why my proof is trustworthy. In my proof, I make sure that everything is clear without skipping through any of the algebra or any explanations. Intuition could fail if one thinks that x times y is equal to the absolute value of x times the absolute value of y all the time. Here's why it needs to be demonstrated, as I did in these cases, that when x times y is negative, then it is less than the absolute value of x times the absolute value of y, since the absolute value of x times the absolute value of y is always non-negative due to the absolute value signs. So, where intuition fails, one may turn to AI. Now let's take a look at ChatGPT's proof. The proof does look pretty convincing at first glance, but when we really analyze it, we can locate its flaws. Before we find those flaws, let me point out some of its strengths. It starts off with the right strategy of squaring both sides of the inequality, and then it properly expands them with the right algebra, and eventually it does get to the right conclusion to prove the triangle inequality holds true. Now, the errors it made was never stating where x and y come from. Like, are they imaginary numbers, are they complex numbers, or what? It should explicitly state that they are in the real numbers, so as for the proof to actually work and for the inequality to hold true. Further on, it speaks too formally, saying that x times y is less than or equal to absolute value of x times absolute value of y is always true. In a proper proof, it is necessary to show the cases that lead to that conclusion, as I have in my proof. Then on this line, it skips all the way to saying that x plus y in the absolute value squared is less than or equal to the absolute value of x plus the absolute value of y all squared, without ever going back to the expanded form here, where we can actually see the x times y and the absolute value of x times the absolute value of y, which it just quote-unquote proved on these lines right here. So basically, ChatGPT's proof is not rigorous, it's not complete, it skips through many steps and explanations to get to the quote correct answer as fast and as easy as possible. I said earlier that where intuition fails is where one may turn to AI. That would be the wrong way to approach this proof, or to approach anything in general. Proof-wise, we have seen how AI can be wrong most of the time and likes to cut corners. Necessary proof standards of providing a basis and explaining our steps matter to make instructions and approaches clear to others who read from our proofs, to learn how to apply them to their proofs, or just to apply them to their learning. We cannot let our brains shrink by turning to AI at any troubling problem that we want answered. We need to be expanding our brains by actually using them and exercising a human's unique ability to think on their own and to problem solve with their own intuition, even if the intuition misleads them. Being wrong now is how we learn to be correct later. It is okay to fail and to be stuck. We need to calm down, relax, take a step back, and then reassess the problem at hand. AI cannot be the one making all of our decisions in life. It's human versus machine, and human must remain in control of the machine, not the other way around. Thanks for listening.